Alrighty, so another concept of fractional indices today. So yesterday we established that if I've got something like a to the power of a half, that is the square root of a. If I've got something like a to the power of 1 on 5, well, that's the fifth root of a. Different to something like this, where if I've got 5a to the half, well, that's the same as 5 times a to the half, which is 5 lots of root a. So those two scenarios there, they're different. Okay, so that's the fifth root, just like we might say the cube root or the square root. That's the fifth root. The 5 is sort of inside that little box there, whereas this is 5 times the root of a. So today we want to extend it out and actually work out what happens if I've got something like a to the power of 2 over 3. Well, we know that a to the power of 1 over 3 is the cube root of a. Okay, well, I could say that a to the power of 2 on 3 is the same as a to the 1 on 3 times 1 on 3. Again, because if I multiply terms that have the same base, I would add the powers. So essentially this is almost like doing the reverse of that. Well, what I will find is that that's the same as the cube root of a times the cube root of a. And if we remember some of our surds, well, that's the same as the cube root of a squared. So the new rule that we're going to add to our little list of rules is that if I've got something like this, a to the power of m over n, we already established yesterday that if I've got something like 1 over n, that's the nth root of a. But what that m does, it means that that's our little power inside the surd. Okay, so if I've got something like m to the power of 2 over 3, well, that's the same as m squared being cube rooted. But if I've got something like n to the power of 3 over 2, okay, well, this time it means that my power of n inside the surd is 3, but then it's being square rooted. If I've got something like 5 a to the 2 over 7, well, this 5 out the front, that just means 5 times. Okay, well, again, my power on top here means that we've got a squared, and that means it's the 7th root as well. So that means we've got the 7th root of a squared, and we're just multiplying it by 5. That's what that 5 at the front does. What if I've got something like this one? I'm going to simplify x to the 4 on 5 divided by x to the 2 on 3. Well, that comes back to our most basic index laws. This is a complicated looking problem, but actually it's not super hard. We would just go x to the power of 4 on 5 minus 2 on 3. Now, how do we get that? It's our simple division rule. If I have the same bases, I do, they're both x, so we're all good there. I can just subtract the second power from the first. So we can go 4 on 5 minus 2 on 3 in your calculator. You get x to the power of 2 on 15. Now, if I wanted to write that in surd form, or without an index, or without a fractional index, I would go and say that is x squared. Again, the power that goes with the x here is my 2. It's whatever is on top of my fraction. And then the root part is the 15. Again, that's the 15th root, not 15 times the root of x squared. That's a very different sort of problem. What if I've got something like this one? I'm going to simplify 27 to the power of minus 1 over 3. Okay, so negative means that I'm going to write that as a reciprocal. Okay, well, 27 to the power of 1 on 3, that's just the cube root of 27, and the cube root of 27 is 3, so my answer there is just 1 over 3. I've got one more here. What if I've got something like 27 to the power of 2 over 3? Okay, well, what I've really got is 27 squared being cube rooted. Now you can put that into your calculator because it's a numerical base, but what we could say is, well, we just established that the cube root of 27 is 3. So really what we've got is the cube root of 27 is 3. So this problem will just become, I could write it as the cube root of 27 squared. I can write that power outside if I would like, which is 3 squared, which is 9. You can use your calculator to confirm that. The other type of problem you might be asked is to go and do this in reverse order. So you might be given something like the fifth root of a to the power of 4. Well, again, that's just a to the power of 4 over 5. If I've got the root of n cubed, well, that's just n to the power of 3. And of course, a square root is a half power. So really, that's the two ways we can be asked to do things. Essentially, this is our rule. If I've got x to the power of a over b, a stays with the x because it's on top, and the b goes in our little surd symbol there. If we're good with that, that's kind of the last rule we'll deal with. And if you're understanding all these, you're doing very, very well.